equal to t squared minus 2, our y of t is equal to 3t. We're going to graph this on 3 different intervals, and you're going to see what it's going to do to the graph. So let's just start by doing this the old-fashioned way, doing it by hand. So our first window is from -3 to 1 for our t values. So we're going to plug -3 into both equations individually, get the x value, get the y value, and then we'll look at how that is actually graphed. So -3 squared is 9, 9 minus 2 is 7, 3 times -3 is -9. -2 squared is 4, 4 minus 2 is 2, 3 times -2 is -6. -1 would be 1 minus 2, that would be -1. 3 times -1 is -3. We plug in 0, we get -2 and 0. And when we plug in +1, we're going to get -1 again and +3. Okay, so if we graph it just from t values -3 to +1, we're going to plot these points just like we would in the regular rectangular system. We're going to plot those x and y points. So I'm just going to do a simple sketch here. I'm not going to worry about it being super accurate. I just want to get a general idea. I've got 7, -9, 2, -6, -1, -3, -2, 0, and -1, 3. So notice t has nothing to do with how I'm graphing this. Now I'm just graphing the x and y points. If I start at my starting point, sometimes you will see parametric equations, they will have arrows on them, and that's just indicating the direction of the motion based on how you progress. So we are talking about, we'll just assume that t is time here. So we started at 7, -9 was our starting point, and we moved towards -1, +3. So a lot of times you will see those arrows on the curve, particularly if the instructions are to graph it by hand. Now, if you graph it on your calculator, you graph it on Desmos, it's not going to show you those, but it is an added detail when you do it by hand. Okay, what if we change our parameter window from -2 to +3? So we've already got our values from -2 to +1. We just need to add a few more here. When we plug in 2, we're going to get the same thing that we got when we plugged in -2, except our y value is going to be +6. When we plug in 3, that's going to be 7, +7, +9. Okay, so again, in this case, we're going to plot all the points from t equals -2 to t equals +3. So instead of starting at 7, -9, this one starts at 2, -6. And then we still have our point -1, -3, -2, 0. -1, +3, +2, +6, and +7, +9. I didn't do a very good job of centering up my graph here. But you notice that the graph still has the same general shape. We just have some different details to it. We started in a different place, and we end up in a different place. Our motion's still the same, and it still kind of looks like part of a sideways parabola if my scale had been a little better, got a little off there at the top. And then if we change the parameter window from -3 to +3, then we're graphing the entire thing. So I kind of end up with an entire sideways parabola here. I'm not going to plot the exact points. I'm just using what I've already done. Okay, I already did the first part, and then the second part This one's just putting them both together. I want to, I can throw them little arrows in there to indicate the motion. So we couldn't graph something like this in the regular rectangular system without doing a little bit extra work. The parametric system gives you the ability to do things a little bit differently than you would necessarily in the rectangular system. Okay, so let's look at doing this on the calculator, and then we will look at doing it in Desmos as well. So the first thing you need to do in your calculator is you need to put this in parametric mode. Okay, so go to mode, and pretty much the only thing that we've ever done in the mode section of our calculator is we have changed from radians to degrees. But obviously there are a lot more options here than just radians and degrees. Right below radians and degrees, you will see what should be highlighted is function, F-U-N-C, function. That's the regular XY rectangular system. The next option is PAR, that stands for parametric. So you need to move your cursor over, press enter so that parametric is highlighted. Okay, so once you're in parametric mode, when you hit y equals now, things are going to look a little bit different. You're not going to see y equals, you're going to see x sub 1t, y sub 1t, x sub, so we can put multiple graphs in here, but you've got to put in an x function and a y function, and the little subscript of t there is saying, well, your variable is now t. It's no longer x, your variable is now t. So we can type in our equation, t squared minus 2 and 3t. So when you click the x now, the variable button x, t is going to show up. If you've ever wondered, well, why does it have 4 different variables listed on there, but all I ever get is x? Well, it depends on what mode your calculator is in. So t squared minus 2 is our x equation, 3t is our y equation. We need to adjust some things. We need to go to our window. When we go to our window, things are going to look a little bit different here as well. Our window, we now have this T-min, T-max, T-step. Well, our T-minimum, if we're graphing the first one, is -3. Our T-max is +1. Our T-step, let's play with that a little bit. Okay, let's start with, what if that's just 1? And then we'll see what happens from there. We don't want to mess with our x minimum and our y minimum and stuff yet, unless we just can't see everything in our window. So now we can press graph. And it very quickly graphs that function there. Now, it doesn't look quite as pretty and curved as what we graphed does. That has to do with the t-step. So if I go back to the window and I change my t-step, let's change it to maybe like a 10th, 0.1. When we graph, you can see there's a little bit more detail in there now, okay? So what that's doing is it's telling the calculator, plug in, starting with -3, plug in -3, -2, -1, 0, 1, okay, etc. Count by ones, but then when we change it to 0.1, it's saying count by tenths, plug those values of t in. So the smaller your t-step is, the more detail you're going to get in this graph, and the smoother the curve is going to look, as opposed to it was a little jagged the first time. Okay, so we can very easily change this from -2 to +3, and we can see that matches our second graph there. And then -3 to +3 as well to match our final graph. Okay, so parametric mode, you go to y equals, plug in the equations. You got to go to your window and adjust the t values depending on what the problem asks you to use, and then you can finally graph when you're using your calculator. And go ahead and write those down because you probably think, yeah, I've got that right now. Give yourself about 6 weeks when it's time for the final exam, and we'll see how many people want to ask me, how do I graph in parametric mode? All right, so Desmos makes things pretty easy, like it does with everything else. So let's look really quickly at how to graph parametric equations in Desmos. Here's how you're going to put it in Desmos. You actually put it in parentheses as if it were a point. Okay, you put it in parentheses with the t squared minus 2 comma 3t. So you put the x equation in, comma your y equation. You put it in parentheses. It automatically gives you the inequality for t. Now, what if you're doing a problem and it doesn't give you a window for t? Then you can put infinity in here. Let's see if I can find my infinity symbol. Where is my infinity? It's under this, isn't it? That's not what I wanted. Go away. Can't get to my infinity under there. That's not helping. It's just not meant to be. All right. Can I type in infinity? Will it? Oh, there we go. If you spell out infinity, it'll put the infinity symbol. Good to know. I was wondering about that. Okay, if you spell out infinity, you'll put the infinity symbol. Now, apparently it does not like it. Oh, invalid domain minimum. Try any number. Okay, well, if it doesn't give you a window, then just pick a really, really, really big number because it doesn't like infinity. And it'll graph most of the entire graph there. Obviously, if I get to a point, it will stop graphing if I zoom out enough. But anyways, that was just a side note there. So in Desmos, you put the x function, comma, the y function. You just put those in parentheses like it's a point. And then the t values are right below it. So Desmos makes that pretty simple. The same deal happens with the calculator. If the problem doesn't give you a specific T-min, T-max, then just put in a really big number, a really big negative number, a really big positive number, because it's not going to allow you to put infinity in the calculator either. Okay, so let's talk about eliminating the parameter, and then we're going to compare some graphs. So example 2, eliminating the parameter. We're going to eliminate the parameter. We're going to use the equations from example 1, and we're going to compare the parametric and the rectangular graphs. If we're going to eliminate the parameter, we need to look at this and decide which equation is easier to solve for t. So which equation do you think is easier, x of t or y of t? Y, right? Because x has a squared t in it. Y is much easier to solve this for just the variable t. So to do that, we just divide both sides by 3. Now, for the sake of simplicity, we're going to leave off the of t notation there. We're just going to say that that's y. So y divided by 3 is equal to our t. We are going to go over here and we're going to plug that into the other equation for t. Same deal here. We're going to leave off the of t notation. We're just going to write that x of t as x. So we replace the t with y over 3. Now we're trying to compare this to the rectangular system, so we need to solve for y. Excuse me. So we need to square the y, square the 9. We're solving for y, so we need to add 2 to both sides. We're dividing by 9, so we multiply both sides by 9. You can distribute that out if you really want to. I'm just going to leave it in parentheses. if we're fully solving for y, then we need to take the square root. Now, little discussion here. Whenever we take the square root, we are supposed to consider the positive and the negative. Technically, that is not a function because it fails the vertical line test. It just depends on what we're talking about here. If we're trying to compare it completely to this graph, we're going to need both the positive and the negative. So y'all don't have to do this, but I'm going to change my calculator back to function mode, and I'm going to plug in this equation. Now, you're probably wondering, how do I do the plus and minus? Well, you do it in two separate pieces. Okay, you do the positive square root of 9 times x plus 2, and you do the negative square root of 9 times x plus 2. Okay, so when we graph that, you should see that it is very similar. It's the same shape as compared to your parametric graph there. There is a little missing detail right here. It's just due to the pixelation of the calculator. It does not have very high resolution screen, so you do lose some detail there at the vertex point of this sideways parabola here. Now, I mentioned this is not a function. It fails the vertical line test. So technically, that negative square root part, we're supposed to leave that off. So if we're graphing this in rectangular mode, technically we only get that top part of our curve there. We don't get both parts. Okay? All right, let's look at part B there. Prove that the point -1, +3 is on the curve. Find the corresponding value of t that produces that point. So I am going to, let's see here, to prove that it's on the curve, let's plug it into the rectangular equation. We could plug it into either one, but let's plug it into the rectangular equation here. X is -1, y is +3. So the square root of 9 times -1 plus 2 is equal to 3. That's our question. -1 plus 2 is +1. +1 times 9 is 9. So the square root of 9 we do know is +3. So it does check out that it's on the curve. We just plugged in the x and the y into the rectangular equation. Now, to find the corresponding value of t that produces that point, we've got to set our parametric equations equal to the x value and the y value, respectively. Now, obviously, the y equation is easier to solve here. We just need to divide both sides by 3. So we get 1 is equal to t. I do want to check and confirm and make sure that that value of t gives me that same, or it's confirmed in the other equation as well. So add 2 to both sides. 1 is equal to t squared, so we square root both sides. So 1 is equal to t. Technically, -1 is also equal to t because we took the square root of +1. So technically, -1 is as well, but we don't talk about negative time, right? Negative time doesn't really make sense. Okay, so let's do that again, just to make sure that we've got it. Repeat part B for the point 7, -9. Okay, so 7, -9, that's an x and a y. We want to prove that it's on the curve. So let's plug the x and the y into our rectangular equation. So we've got the square root of 7 plus 2 is 9. 9 times 9 is 81. The square root of 81, it can be both positive and -9. So that is confirmed. find out what value of t gives us those points. So our x is 7, so we set that equal to our x equation. Our y is -9, we set that equal to our y equation. Again, the y equation is easier to solve. We do get -3 here. So when we solve the x equation, we add 2, we get 9, we take the square root. The square root of 9 is both positive and -3, but since the y equation gave us the -3, then we're going to say that the t value is -3 here. So we don't know the context of this problem. T does not always correspond to time, especially if we don't have a context. So it is possible to have a -t. We started graphing with a -t. So it is possible. You just have to check and see if there's a context or not. Okay? Questions about that? Okay, let's do one more eliminating the parameter problem, and then I'm going to let y'all do some practice problems here. So example 2b, we want to eliminate the parameter here. We've got x is equal to 1 minus 2t, y is equal to 2 minus t. Let's see here. I would say that the y equation is, again, easier to solve for t. Now, a little weird here because we have a -t. Personally, I would add t and then turn around and subtract the y, just so that you don't have a -t and have to make sure that you get all your positives and negatives in the right place. Okay, I would make t positive by adding it and then move the y to the other side. So then we can plug that into our x function, plug in 2 minus y for t. Distribute the -2. -2 times 2 is -4. -2 times -y is positive 2y. So we've got x is equal to -3 plus 2y. Again, our instructions didn't really tell us what to do. If you're going to graph this to confirm that the parametric and the rectangular are the same, you do need to solve for y. So x plus 3 over 2 is equal to y. That's if you're going to use your calculator. Let me show you something really neat about Desmos. You don't have to have it solved for y for it to graph. So let me get rid of that real quick. Let's see here for equations. 1 minus 2t and 2 minus t. 1 minus 2t, oops, and 2 minus t. It didn't give us parameters, so I'm just going to go -100 to 100, okay, so that I can graph enough of that. Say I didn't solve my equation for y. Say I just left it right here. X is equal to -3 plus 2y. X is equal to -3 plus 2y. Guess what? It'll still graph it for me. Okay, I don't have to have it solved for y. And look, another good thing about Desmos is I can graph in parametric form and in rectangular form, and I don't have to change anything. I don't have to change my mode or anything like that. I just want to confirm it. I would click this button right here and make it appear and reappear and make sure that it's in the exact same place. And it is the exact same graph. So that confirms that your rectangular and your parametric forms match up there. Okay, any questions about graphing or eliminating the parameter?